Hi guys, I am Yashodhan Agnihotri, a final year student at IIIT Pune, and I will be your host for today. Welcome to our channel, Learn Competitive Programming with CodeChef. On this channel, we post weekly problem explanations and concept videos. Also, if you are interested in competitive programming and want to master data structures and algorithms, this is the place for you. So, what are you waiting for? Click on that subscribe button and kickstart your journey towards competitive programming today. Also, did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic related to competitive programming? We have beginner level courses like Introduction to Programming in C++ or Java, Recursion, Basic Data Structures, or advanced level courses like Graph Theory, Dynamic Programming, and Segment Trees. These courses are conducted by top coding experts who have been ICPC World Finalists, IOI medalists, and work in top product based companies like Google, Amazon, Facebook, and LinkedIn. All you need to do is download the Unacademy app and choose your goal as competitive programming. You can also take the paid plus subscription to get additional features and individual level support. In plus, we have a large set of practice problems associated with every topic covered. Also, we have 6-star and 7-star teaching assistants to help clear your doubts during and after the live sessions. You can use my referral code, which is ZAP10, to subscribe for the plus classes and get an instant 10% off. So hurry up and don't miss out on this amazing opportunity and kickstart your journey towards competitive programming. The problem in discussion today is from the recent December Long challenge. The name of the problem is string operations. The difficulty level of the problem is medium and there are no prerequisites for this problem. Let us see the agenda for today. First, we will understand the problem statement. Next, we will see the detailed solution approach. Lastly, we will see the pseudocode followed by the C++ implementation of the problem. Now, let us try to understand the problem statement. Two strings A and B are equivalent if they have the same length and A can be transformed into B by performing the following operation 0 or more times. Okay, so the operation is given as follows. We have to choose a substring of A which contains an even number of ones. So 1 has an even occurrence and we have to reverse this substring. So if by reversing such a substring, if A is kind of converted into B, then A is considered equivalent to B. Now let us come to our problem. We are given a binary string S. We have to find the number of different equivalence classes of the substrings of the string. In other words, we have to find the smallest possible size of a set C of binary strings with the following property, that for each non-empty string R, which is a substring of S, there is a string X belonging to C such that R is equivalent to X. So basically what we have to do, we have to count all the unique substrings of S. So if we are given the binary string S and we have to count all the unique substrings of S, provided we count strings like 0011 and 1100. So both of these strings are equivalent. So they are the same. So these strings are not unique because they are the same. So considering both of these as same, we have to calculate all the unique substrings considering such type of strings are equivalent. I will explain this to you with the help of a sample case. Let us understand the problem better with the help of a sample case. Here we have a string 10110 as you can see over here. Now let us try and find all the unique substrings of this string. So we will find the substring according to their length. So of length 1, all the unique substrings are 1 and 0. Of length 2, the unique substrings will be 10, 01 and 11. For length 3, the substrings will be 101, 011 and 110. For length 4, the substrings will be 1011, 0110 And for length 5, that is the maximum length, the substring will be the whole string. So 1 0 1 1 0. So this is our set of substrings. Now let us try and find out the equivalence class for this set of substrings. So for finding the equivalence class, we will determine if any of these, if any pair among this substring set are equivalent. So let us check. So 1, it is unique, 0, it's unique, 1 0 and 0 1. Though 1 0 and 0 1 are reverse of each other, they contain an odd number of ones. So therefore, they are not equivalent. Let's check further. 1 1, it is unique, 1 0 1, it is again unique, 0 1 1 and 1 1 0. So 0 1 1 will be equivalent to 1 1 0 because their lengths are same and they are reverse of each other. Also, they contain an even number of ones. So these two strings will be considered equivalent. So let us erase one of them. So let us erase 0 1 1. Moving further, 1 0 1 1, yes, it is unique. 0 1 1 0, yes, it is also unique. And finally 1 0 1 1 0, yes, so this is also unique. So now let us see what is the size of our substring set which we had finally. So 1 2 3 4 5 6 7 8 9 10. So the answer for this test case will be 10, as we have 10 elements in the substring set, that is in the equivalence class. Let us move on to the detailed solution approach. So the task at hand over here is to uniquely identify strings of the same length. So what we have to do is that 1010 and 0101, these strings are equivalent, and also 1011 and 1101, these strings are not equivalent. So we have to devise an implementation such that these strings are identified as same and these are not identified as same. So as you must have realized, this question is mainly an implementation problem. So let us see how we can implement this. Let us see the implementation for this problem. These are the two tasks that are at hand. First, all pairwise non-equivalent strings should be uniquely identified. That is 101 and say 011. These are not equivalent, so these should be uniquely identified. And next, each equivalent pair of strings should be identified as 1. That is 1010, which is equivalent to 0101. So if these two are substrings of a certain binary string, then these should be identified as one single string. Let us see the main idea for implementation. Here, let count represent the count of ones in the string that we are considering. So this string will be a substring of the binary string that we are given. So the task at hand is that for any particular substring, we have to identify some parameters that will help us uniquely identify the string. So the first parameter is the length. So if we have a string 10101, so the length is 5, and this will help us differentiate the string from strings like 1010. So this is length 4. So this is one parameter. The second parameter is even count of ones, and third parameter is odd count of ones. So let us see what these two parameters mean exactly. Let us understand this better with the help of an example. So here we have string 1011001. So it has length 7. So this is parameter 1. Now let us see what are the even and odd parameters for this. So over here, the even and odd parameters mean that for each occurrence of 0 in the string, we will see if there are even number of ones before that 0 or odd number of ones before that 0. So let us see. For this 0, we have 1 occurrence of 1. So here odd will be incremented by 1. Now for the next 0, we have again 3 ones occurring before this 0. So again odd will be incremented. Before this 0, we again have 3 ones. So again 1 will be incremented. Now let us see the same example for the exact reciprocal or the reverse of this string. Now we have the reverse of the previous string that we took as an example. So the string we have is 101101. So the first parameter is length is equal to 7. So this parameter is matching. So let us go and check the number of ones, the parity of the count of number of ones that occur before each zero. So this is the first zero. So the number of ones that occur before this is 1. So it is an odd number. So 1 over here. Before this 0 also 1. So again odd. And before this 0 we have 1, 2, 3. So there are 3 ones, which is again an odd number. So if we write the parameters for both of these strings, it will be something like 7, 0, 1, representing as length, even and odd. Sorry, my bad. It will be 7, 0 and 3. And for this string also it will be 7, 0 and 3. Now if you see, these parameters exactly match for these strings. Also, did you notice that these two strings are equivalent to each other? Because if we write these strings 1011, 001 and 100, 1101, these contain an even number of ones. Therefore, as they are reversed, these strings will be equivalent. Now, let us try to prove why this solution works. Consider this. We have a binary string with even number of ones given to us. Now, I've depicted this string randomly. So now we know that this contains an even number of ones. Now let us consider this position, this 0 position. So over here, I have represented x as the number of ones occurring before this position, and count minus x as the number of ones occurring after this position. So count over here represents the number of ones. Now, if you notice over here, x plus count minus x, this is equal to count, which is even. So this is even. Now there can be a total of maximum 2 possibilities. Either x is odd, therefore count minus x will also be odd, or else x is even and count minus x is also even. So did you notice, if we are assigning a particular parameter to this 0 in the normal string, then in its reverse string, if we are assigning some even is equal to x, and in its reverse string, even will also be equal to x, because for each 0 the parity of zeros before and after it is same. This will be the same for odd as well. Therefore, these two strings with the same length, having even number of ones in it, and being the reverse of each other, both of these strings will be equivalent to each other. Therefore, we can state that if length, even count and odd count are same, then two strings are considered to be equivalent. Let us see another example to prove that strings not following the parameters are considered non-equivalent. So here we have the string 1011 and here I have its reverse string 1101. Now if you see, these strings have odd number of ones. So technically they should not be equivalent. Now let us see. So the length of this string is 4. So here I will calculate the number of ones which occur before the 0. So here it's 1. So it's an odd count. Now here I will check the length, it's 4. Now I will check the number of ones that occur before the 0, it's 2. So it's an even count. Now if you see, the parameters for these two strings are 4, 0, 1 and 4, 1, 0. So as the parameters are different, then these two strings are not equivalent. Now let us see the pseudocode for this problem followed by the C++ implementation. Now let us see the pseudocode for this problem. First we will take inputs, that is the string s. Next We will check that in every substring, we will keep a count of one's occurrences before every zero. And as we saw in the solution approach, that this occurrence should be kept on the basis of parity. Now, we need to differentiate between the strings using length, comma, even, comma, odd as the parameters, as was discussed in the solution. And this should be implemented with set, because a set allows us to uniquely identified parameters given as input. Now let us see the C++ implementation. So let us see the C++ implementation for this problem. First, we will take input the string s. Next, we will define necessary variables like n, which is string.length, and also now let us define the set which will contain our three parameters, that is length, even, and odd. So let us name this set eq for the equivalence classes. Now let's run a loop, outer loop, for each character, and now the inner loop for each substring. But before that, I will initialize count is equal to 0, even count is equal to 0, and odd count is equal to 0. Now the inner loop for each substring, it will run from I to n. Now over here, if we have s of I, if we have s of j, that is the character in the substring, if we have it equal to 1, then we will increment the count. Else, if count is odd, then we will increment the odd variable. This shows that we have the 0th character and we are incrementing if the number of ones before that particular 0th character are odd. Next, if the count is even, then we'll increment the even variable. Now at last, we will calculate the length. The length will be j minus I plus 1. So we will insert this into the set which we had declared earlier, that is eq. So eq dot insert length, comma, even, comma, odd. Now the implementation is almost done. Now we just have to output the size of the equivalence set. So that's it. So now let us submit this solution and let us hope for a correct answer. But before that, before I had written I less than n I plus plus. So it should just be j less than n j plus plus. So note that. And now let us submit our code. There, we got an AC. This winds up the video. Thank you for watching.